There was, I don't remember exactly where I read it, but someone said in the wild, if, for example, a zebra meets a lion, the stress response gets activated, they run away. But after that, they settle down and it's gone. They forget about it. The zebra does not stay in that state. Whereas us humans, we tend to.
No.
And I think that's where problems.
Yeah, Robert Sapolsky has written a lot about that. Yeah, you have this book, Why Zebras Don't Get Ulcers. That's I can recommend. It's a very, very good reading.
I've heard about it.
No, I mean, that's true. And also, yeah, what we should remember is that, I mean, all these responses that you activate with stress, like the sympathetic nervous system, the adrenal medulla that I just talked about, but also the other part of the stress response, the cortisol, so the hypothalamic pituitary adrenocortical axis that results in release of cortisol. Both of those systems are actually, we can't really say that it's stress all the time when we activate those systems, because they are systems that we use to mobilize energy that would support our normal behavior. So it's quite interesting if you look at animals. Jaap Koolhaas in the Netherlands have written a lot of papers about that. If you look at different kind of stimuli that you give, he's working mainly on rats. So even rewarding stimuli. I mean, if you have a rat male and you give him access to females, the sexual partner, you get a huge increase in cortisol and adrenaline and noradrenaline, especially in the circulation. Because preparing for, he's mobilizing energy. So I mean, that makes it very hard to define what stress is. Actually, you can't just go out there and measure hormones and say that this individual or this animal is stressed and this one is not, because so what's really seemed to be stress, and that's something that's been written more about during the later years, is that when you lose control and so when you can't predict and you can't control the situation, then something bad is happening.
So if it's more psychological for us, it has to be in the brain, my brain. I have to decide I'm not able to control this any longer. And that's when the stress becomes negative.
Yeah, and that's actually the same in the fish. So it doesn't have to be a human.
Oh, interesting.
So it's cognitive processes. So if the animal or the human feels or perceives that it has control, maybe you don't have control, but you think you have control, right, then it's fine, or it's better, because then the stress response goes down much quicker.
Right.
And if it's predictive, then it goes down. And there is also like a shift. If you look at the catecholamines, if it's a non-predictable, uncontrollable situation, you get a lot of adrenaline into the blood. But if you get a more controlled, predictable situation, then adrenaline really goes down, and instead noradrenaline goes up, which is more important to mobilize the right kind of energy substrates to meet whatever behavior you're doing. They did quite an interesting study on rats with the forced swim test. And these were laboratory rats, so they were not used to go swimming. Otherwise, I mean, rats, they're quite fond of swimming, so it's not a big problem for them otherwise. But the first time they put them into the swim channel, they had them cannulated so they could measure hormones. They got a huge increase in adrenaline, cortisol, and also. Or corticosterone, as rats have. But then if they repeated, the adrenaline really went down. Instead, noradrenaline went up. And if they looked at what energy substrates they mobilized, they got more fat into the circulation, and blood glucose levels stayed quite low. So then they prepared themselves for swimming. So they were not experiencing what we would call stress, but they were preparing for the swim that they were going to take. So the cognitive processes are really important here. I mean, that's...
So basically here as well, a lot of people today with different diets that are out there, how to control, not just from fat burning, our health. And one of the most popular diets nowadays is the ketogenic diet. And the whole point is to keep insulin and essentially blood glucose levels down, basically. So do you think that the mechanism behind it is exactly the same? So basically when blood glucose levels rise to a level where they shouldn't be over an extended period of time, and therefore insulin will rise and over and over and over and over, where it will lose its ability to control the blood sugars, that is definitely, or is it a possible contributor to all sorts of diseases and inside the human body?
Yeah, it probably is. I mean, insulin is, I mean, also acting like a growth factor, so it probably affects things like cancer and other things. And then also, of course, diabetes type 2, I mean, which is increasing rapidly in society. And that could, of course, also be related to stress, because if you have this constant stress, you try to increase your blood glucose levels. Insulin will go up, but the stress makes insulin have less of an effect. And I mean, if you go on like that for a long time, could be at least a contributing factor, I think, for diabetes type 2.
Exactly. Now, the other thing I would like to mention or talk about here is, generally speaking, we always talk about the flight or fight response when we talk about stress. Now, according to certain theorists, there is also a freeze response, which is basically an immobilization or a shutdown of all the body systems. And here I'd like to ask you a little bit about your opinion on the validity of this theory and this reptilian brain connection and the polyvagal theory. I would like to get into a bit.
Actually, I don't give that much for that theory, to be honest. I mean, when I saw your question there, I went in and read some papers and some reviews about it, and they claim, the ones that talk about this theory, they claim that there are differences, that we differ from other mammals and reptiles, amphibians and fish, in that our vagal system should be organized in a different way, which is not really, I don't think that's the case. And I mean, of course there are species differences, there are lots of species differences. But I mean, if you look all over the vertebrates, from fish up to mammals, and mammals including humans then, you see this huge difference within species in how to react to stress. And there you have this, I mean, you have the freeze response. The zebrafish we are selecting on, the shy ones, they get more of this freezing response.
All right.
Whereas the bold ones, they get much more of this active response. So it's something that differs between individuals. And of course, it also differs between species. But I don't think you can say that there is a huge difference between mammals and reptiles, for instance, because these are evolutionary, highly conserved systems. And they work very similar, even if you go to the fish and compare to the human, to the mammal. It's more or less exactly the same. So I think where you can see this really big difference, that's between individuals. So if you stress any animal or human, what usually happens is that you start out with this active stress response. I mean, you try to get away or to fight this bad thing that's going to happen. And if that is not successful to regain control, then you switch over to this passive. So the difference between individuals, that is when to switch to the passive.
Interesting. Okay.
So some individuals, they go on fighting to the bitter end. I mean, they never go over to the freezing response. They continue fighting until they die. Right. But others, they switch to the freezing much earlier. And that's related to what we call personalities. If you are the more, what we biologists call the proactive type, then you keep on being active. If you are more of the reactive type, then you switch over to this freezing, the passive response.
And that you think is determined basically by your genes? And there is no environmental impact on
I think there is a combination, actually. The genes are definitely important here, but I think there is also a combination interaction between the genes and the environment, and that's a little bit what we are after in the zebrafish experiments.
And do you think that there is a possibility to influence these very reptilian, very basic neural circuits and responses in humans? Because we have what the zebrafish don't have. We have consciousness and cognition, right? So we can achieve basically with our evolved brain a lot more.
There is a lot of discussion about how much consciousness we have in the fish, but
yes.
maybe that's out of this. But they don't have conscious at the same level as us, so we can agree on that, and not cognition either. But they have the same kind of mechanisms. So I think we should not see ourselves as so special. We have our special adaptations, they have theirs, of course, but we are much more similar than people in general think. I mean, it's not that much difference in the general build-up of a fish and a human. We have the same kind of systems, and if you look at the brain, for instance, it's more or less the build-up of the brain is more or less identical between fish and a mammal. What differs is the size of different brain areas, of course, because in our brain, the cerebral cortex is huge. So that's probably why we sit and discuss here now. But I don't think the fish would discuss their stress response. But so that's of course a big difference. But I mean, the general structure, the build-up of the systems, it's very, very conservative, more or less identical.
Okay, but basically this analytical mind that we have, and what you're saying, they probably do not to the same extent as us, and we do analyze and overanalyze sometimes things. But the question is that are we, or could we consciously influence the so-called autonomic nervous system that normally in textbooks, this is just happens by itself basically, and these are all most basic reactions. But do you think that there is a way to get in there?
There probably is cognitive, since cognitive processes are very important for the stress response. We should be possible to dampen the stress response, but we also have this, our intelligence and cognition is also bad for us in some situations. We have this that we start to imagine things. You can lay there in your bed and think about all the bad things that are going to happen to you. I usually tell the students, you sit there and you think that you're going to fail on this exam, and if I fail on the exam, then I won't go and get any new student loans, and then I can't continue my education, I would never get a job, the whole life is ruined. But you're still laying in the bed, nothing has happened, and you activate all these stress responses. Yes. So that's a really bad thing. And that, of course, you should not do. And with your cognitive capacities, you could try to avoid such things, perhaps.
Well, exactly, but the other way around, rather, to make sure that these responses that are activated exactly by thinking, maybe that's where meditation comes in, but I would like to talk about that a little bit later.